idea of what the real world looks like out there. We see the depth, we can tell how far away we are, we can tell whether we're off to the right, and we can see we have azimuth stability and directionality, and if we close one eye, a lot of that vanishes. The world becomes very flat. Our hearing mechanism works the same way, conceptually. When we hear sounds in real life, for each event, we hear 2 arrivals, one for each ear. And each one of those arrivals arrives in a slightly different way, a different time, from a different direction, even from a different altitude. And believe it or not, we can tell azimuth because we have these fleshy things on the bottom of our ears. These things tell us how high something is when we listen to it. Now, when we play back stereo, unfortunately, each ear hears the sound from one speaker. So we hear this. Each ear hears 2 sounds, and there are 2 speakers, so that's 4 sound arrivals instead of 2, like in real life. Double vision, and it's difficult. It's extremely difficult to make that double vision go away. Now, we as audiophiles work hard at doing that. We have special speakers that, and we have special rooms and special room treatments. We work extremely hard to make the double vision aspect of our listening experience vanish or minimize. And that's when we get a beautiful soundstage, beautiful front-to-back depth, and it sounds very sweet and very realistic. But it's so hard to get there. The way these speakers work, oh, by the way, when we have our stereo systems and we're listening to them and it's sounding really good, lots of depth, lots of believability, a lot of sweetness, it's really because that loudspeaker is in many ways getting rid of the double vision by canceling, not really canceling, but minimizing the unwanted double vision components in the sound field and enhancing the ones that actually construct. It's by destructive interference and constructive interference. Both are working. Now these speakers have 2 sets of drivers on either side. One over here and one over here. They're side-firing drivers, and the delay, the time delay associated with the sound going around the speaker and mixing in the front is the same as one intraoral time delay, which is nothing more than the spacing of our ears and how long it takes sound to go from one ear to the other around our head. It's about 800 microseconds if you have a big head. About 600 microseconds if you have a small head. And fortunately, it's not too critical. It doesn't take very much in the way of a set of clues and cues for our ear brain to latch onto and make a sense of acoustic space. That's what I was after. And I was turned on to acoustic space, front-to-back depth, by Harry Pearson years and years ago. He was big into that. He was the first guy that I ever met that talked about it. To me, at that time, I was very young. My God, I was young. I'm old now. It's not my fault, though. Don't blame me. But stereo was a flat curtain of sound between 2 speakers. I remember I'd have a speaker here and I'd have a speaker here, and there were the Beatles. Boom, boom, boom over here, and then boom, boom, boom over there. Oh yeah, that's great, that's stereo. And I had left and right, and other than that, it was a flat curtain of sound. I could have had a clothesline strung between the 2, and it was pan-potted stereo. And that's what I was brought up with. That's all I had experienced until I met Harry. I was over at Harry's place in New York, and he said, Bob, come listen to this. And I did, and it literally amazed me. I was taken aback by what I heard. I heard this enormous front-to-back depth, space that expanded beyond the confines of the speakers. Even altitude information came in. And I was sitting there going, oh my gosh, this is amazing. And he was reviewing my phase linear amplifier at the time, a phase linear 700. It was his first magazine, my first amplifier. It was the, and I went home and I had to figure out what was going on. How did they do that and why did they do that? Harry hadn't a clue. But he knew he knew that there was something special there, and he showed it to me. So, as the years have trolled by, and these speakers represent the concept that started right then, all those years ago. I think it was about 77 or 78, 1977. And these speakers make a wavefront that has contained in it interaural time delays. And our ear brain latches onto those interaural time delays and makes acoustic space, makes something that's more believable than if it wasn't there. And so that's basically how they work. The side-firing drivers build the space. The forward-firing ribbons, these guys here, place the images inside of that space. So when we listen, the idea is that we have a large acoustic space, but we have nice pristine images inside by virtue of the forward-firing ribbons as a line source. Now, so there's some trickery there, and there's trickery in the amplifier. I hate to use the word trickery, but I'll just sort of make fun of what it is a little bit by using the expression trickery. But in the amplifier, it was the listening to the room. In the loudspeakers, it's the interaural time delays. And also, if you listen to a line source, all by itself, just a straight-ahead line source, the images will be at ear level, exactly at ear level. It's probably better to have them at ear level than down on the ground if you had a point source speaker. I don't like my symphony orchestra and orchestra pit anymore. I've been down at the opera these days. The orchestra's on the stage now. They got rid of the orchestra pit. And it's much nicer. The singers are right with the orchestra. So I wanted to say goodbye to the orchestra pit. And I also wanted a believable image. So I had Peggy, my wife, when I was designing these speakers, stand in the center of the speakers and speak. And I wanted to make the reproduction of her speech, or any singer's speech, be at ear lip level, so it was more realistic. So there are circuits in here that pull the image up, so it's not here at ear level. Rather, you'll notice it comes up to about here. And that took some special doing. So when I started this talk about speaker, I said that they're going to fly in the face. The conceptual underpinnings of how they work flies in the face of what we've been taught. Here's what we've been taught. Have the woofer go out and have a nice crossover, and then have the upper bass driver come in, have it go out, have it die, have the mid-range driver come in, have it go out, have it die, and then have the tweeter come in. And if you're on a Nudell of infinity, you'll add a super tweeter that'll take it out to infinity. Pardon the pun. But when you build a speaker like that, it can sound great. It really does. But it doesn't sound spectacular. It doesn't engage you emotionally. And the reason is, it's double vision for openers, and it sounds too low, and a little tweeter really can't hold a candle to a big ribbon with all the area. A little tiny tweeter, it's got half a square inch of radiating area, where those have several hundred. So these can put out sound with unimaginably low distortion, because they're hardly moving at all. There's so many of them. The output of a loudspeaker is the area multiplied by how far it moves back and forth, just like a car engine, cubic inches. cubic inch displacements. So if you have a little baby tweeter, it's moving, has to move a lot to make sound, and it makes distortion because of it. It goes nonlinear. And it's very obvious when you listen to it. So those are some of the features in the loudspeaker. These things, the crossover network in these makes the drivers, instead of going to their band limit and then dying, it actually embraces a large overlap, which many of you, if you've built your own loudspeakers, have probably experienced that. You like 6 dB crossovers better than 12 dB crossovers. Yeah, I'm seeing some heads nodding. And it's because when you do that, when the music's playing, you get a lot of cancellation, a lot of the double vision aspect goes away. And not only that, you get some reinforcements by statistical accident and associated with the music itself that can give a better sense of space and realism, just because you've had a driver that you can do that with. So many of you have experienced that, and these are designed with great intent and with intentionality to have that large overlap. The side-firing drivers actually go up to around 12 to 15 kilohertz. I don't run them as along that. They're not run at that level. They're reduced in level by about 8 dB. And guess what? By the magic of acoustic action, that 8 dB is similar to the attenuation that one ear has relative to the other ear if a sound's over there. And so it does it in amplitude as well as time, because the time delay is about the same as an interval time delay. The sound takes to get sound to get from one side to the other. It's hard to believe all of that, but if we listen to the speakers, these line sources, and if you want to prove it to yourself, just kill one side of the speakers. Just stop the left side or the right side drop from playing, and this beautiful sound stage just collapses. And it loses a lot of its front to back depth. Yes, sir?
What's the tweeter on the very top do compared? How's that evolved in the speaker's design?
That's in there because one day I was complaining to Arnie Nudell. I said, Arnie, there's something wrong when I don't have a ceiling that matches the speaker height. And in my room, my room's high, and so the speakers, there's some spacing there. So that tweeter helps couple an imperfect room to the ribbon itself. It helps it think it's a line source, even though that mirror on the top is not right on the speaker.
Does it have more vertical dispersion than the other ribbons do?
Yes, you'll notice it's sideways.
Yeah.
You see, and that makes the dispersion go like this and go like that. Whereas these, the dispersion goes like that, and no vertical, to speak of, no vertical dispersion. And so I was talking to Arnie and I was complaining. I said, Arnie. And he said, Bob, you gotta put a tweeter in the back. You gotta put a tweeter on the top and face it backwards. He said, Arnie, you're kidding me. But it's Arnie Nudell I'm talking to now. Gosh, I'm not gonna argue with him very much. But I did a little bit, and he said, try it, just try it. Put a speaker on the top and aim it backwards, and your problems will go away. So I did, and poof, my problems went away. It fixed the thing I didn't like about him. And so I called Arnie back, and I said, God, Arnie, how'd you know about that? And he said, oh, Bob, I've been designing speakers since I was 2 years old. That's how. So I did, but the problem was, it looked funny, because there's this speaker, if you look at it, it goes like this. I'm looking at it from the top, and it's like a little bullet shape. So it looked funny with the tweeter aiming out the back. So I turned it around and put it in the front, couldn't hear any difference. It worked just the same, as far as I could tell. So I called Arnie and said, Arnie, guess what? It works just as well aimed forward. He says, oh, no, it can't. It's got to aim backwards. So I was right. He was wrong about that. But it was because of the unique feature And I learned that the way it works is a little different from the way Arnie thought it would, and the way I thought it would initially. But it helps couple the top of the speaker to the ceiling. And I was thinking of it in terms of distance, but when I look at this ceiling, it's got a similar problem. It's just it's a lot of sound absorbing material. So that's a very good question, very good question. Yes, sir.
Can the amplifier, this is back to the responding to the back EMF on the side firing drivers, does the amplifier discern between the back EMF that comes off of the mechanical and electrical characteristics of the driver itself from the things that it's getting that in time delay off the walls and stuff?
Oh, yeah, the speaker having its own signature, it vanishes. And that's simply because that part of the speaker is responding to the forward drive signal. That is, the feedback that's hooked up at the top of the drive transformer, output transformer. And it would, in a transistor amplifier, it'd be the actual driving node. Whereas the feedback that you're asking about is in the bottom leg of that driving node. Completely different signal. Good question.
So is this feedback all happening in the analog domain?
Yes, it's all in the analog domain. Yeah, I wasn't clear on that. It made it, the way I talked about it a little bit initially, it made it sound as if maybe there's a computer in there, but there's not. This is a very vintage amplifier design. The only thing that's not vintage about it is how much power it has, how much energy storage there is, the DC restorer, and the feedback system of listening to the room. I guess that's a lot. It's really not a very yeah. Yes, sir.
How difficult are these speakers to drive, notwithstanding that you have your own amps and speakers that work great
Well,
together?
actually, they're pretty easy because of its back. Because it's a high back. I'm big on high back EMF and high box pressure. It started with my subwoofer, and when I had these reviewed by the Absolute Sound, I took them to Robert E. Green's, who reviewed them. One of the best reviews I ever had in my life. And I was worried that he wouldn't have a good amplifier to drive them with, so I took one of my little tube amps, my little tiny ones, which only have 20 watts. Easy to drive. I was completely happy with the way they sounded, and I left those two little 20-watt amplifiers with him, figuring that he would hook up the big ones when I sent them to him. And so I think I brought them with me. I can't remember. No, I sent them. And they stayed in his garage for months until he finally got around to hooking them up. He was completely happy with the little 20-watt amp. But he did say that when he hooked up the big amps, oh, it got better. It really got better, so he said. Yes, sir.
So if these are used with other amplifiers without the feedback corrective circuit, will they sound worse?
If the amplifiers are used with a
No,
different
if
speaker.
other amplifiers are used without the feedback circuitry.
Oh, they'll sound great.
They will. So
Yeah, they will. It's a property of the amplifier, so think of it as, here are these great speakers, like a Stradivarius. The speakers are the Stradivarius in your living room, or outside, or in your bathroom, wherever you play your Stradivarius. One Stradivarius, two Stradivarius. And when you add the amplifier to it, it changes the sound.
Okay. So the speakers could be bought just as a speaker system.
That's right.
Okay.
That's right.
So you have separate feedback lines coming off the speakers in addition to the cables going to the speakers, or is it just a single pair of cables?
Just the single. The question was, is there a separate set of wires to carry the feedback signal? And there's not. It's the same set of wires that drive the signal. The signal goes both ways.
So along the same lines as the question before, what about just the purchase of the amplifiers without the speakers?
It turns out that the amplifiers will listen to the room even with other speakers, because all speakers, at least if they have a back EMF, and all speakers do, when they move back and forth, they generate a voltage. I'm trying to think of if there is a speaker that won't do that. Let's see, a piezoelectric one will.
Electrostatic.
Electrostatics?
Electrostatics, no, electrostatic would.
What about the MIT loudspeaker cables with their Zobel networks inside?
You know, I've never tried one. It maybe wouldn't work
That,
so well.
that one went so
But
well.
I don't know. I don't know. I would have to try it. Let's see. It's sort of, the Zobel network's sort of like a little EQ